All right. So before what we did is we created a Boolean expression from a truth table. Now what I want to do is do another example. So this is chapter 4, part C. So I'm just still in the truth table in 4-3. I'm just doing a couple more. I'm doing one more example for you. So let's say that I created a truth table, and out of this truth table, my ones actually appear right here. So if I look at my ones right here, and this is from an arbitrary circuit, whatever it is, something out that's out there. So I just created them myself. So if we look at these ones, we have three of them. So we're going to have three equations. And we know that this is going to be A naught, this is going to be B, and C naught. So A naught, B naught, C naught. Second one is going to be A naught, B, C. A naught, B, C. And the third one is going to be A, B, and C naught. So this is A and B and C naught. So we have these three equations. So we know that these three equations, when we put them together, are going to be ordered. Again, when we put these three equations together, we're going to order them. So in this case, we're going to take this one, A naught, B, C naught, this is right here, and we're going to order it with A, B, and C. So we're going to order it with A naught, B, and C. And then what we're going to do is order it with A, B, and C naught, A, B, and C naught, and that's going to be a Y. So generally, in the beginning of this class, you're going to be getting this and this equation, and this will be correct for me for now. But eventually what we're going to do is we're going to learn how to reduce these down. So let's actually see if we can actually reduce this down any further. Slowly but surely, let's take a step by step here. First of all, we notice that there's a common B in here, and all the B's are not inverted or anything. They're all the same. So we can actually break that out a little bit. So I can take B, and then looking to see if there's anything else. See, nope, there is nothing else. So I'm left with this A naught, C naught, ORed with A naught, B, and then OR it with, not B, A and C. I made a mistake, so that should be C, A and C. And then OR it with, to B out, so I'm going to OR it with A and C naught. So now I could look at this and say, okay, can I get this any further down? Probably, and I start breaking it down. But I'm going to say at this point, if you did this part of it, that would be good. We keep going, breaking it down here a little bit better. We would have to, I don't know if this can be, I don't think this can be broken down any further. So I'm going to say that's going to be left alone as is. I'm going to be very cautious of saying that, but I'm feeling pretty confident that this is as close as possible. But like I said, this would be the correct way of doing it. So again, this is 4-3. All right, so basically the 4-3 is covering truth tables and how to come up with Boolean expressions. Now we want to do is create the combination logic gate for that. And I took this thing one step at a time right here. So we can first figure out the truth table, how to come up with the equation. Now we want to do is take the equation and come up with the logic gate on this. So in short, let's continue on this. It's a little adventure. So the last one we did actually was B naught is equal to Y. Well, believe it or not, this is really the simplest one. This is B naught. So this is just a NOT gate. And that's this one right there. The other one we had was, the other equation we had was A, B, and C naught, or with A, B, C, or with A, B, C naught. And that's equal to Y. So let's look at this. We have an OR gate, a three-input OR gate, a three-input AND gate, three-input AND gate, three-input AND gate, three-input AND gate. And then we have two OR gates right here. So we got a couple ORs. So this one's going to be ORed. So this is going to be actually a three-input OR gate right here. So what we're going to do is we're going to take these three ANDs, and then we're going to have some NOTs, and then we're going to have ORs. So this is going to be actually going to be a three OR gate. My mistake. It's a three OR gate. So because we have three different parts right here. If you think of this one, this is going to have some sort of output. This one's going to have some sort of output, and this one's going to have some sort of output. So we can actually say there is going to be the final part of this is going to be 1, 3, and 4 OR gate. So let's get these ANDs first. So let's get my power lines first here. A, B, and C. And let's say that I'm going to use this. I'm going to draw it out this way. So I'm just going to start connecting up my power lines down here. And what I want to do is take my first AND gate, my first set right here, my AND. And what I'm going to do is pop 3 inputs. There we go. So I got A. So this is going to be, we'll call this A. A naught. This is going to be B. And this is going to be C naught. There's my first one. So A naught. So 3 input AND gate. This is my AND. All right, next one, my next AND gate. Next AND gate is just A naught. So actually I could just take this pipe, this one down. Draw it out. So there's that. So I don't have to get another AND right there. There's that one. Now I got B and C. So I take B down right here. And then C down right here. So this is becoming pretty straightforward. So I got A naught, B and C. B and C are not inverted. And I have an output right here. And my third AND gate. So I got my third AND gate is C is going to be inverted. So I'm going to take A and B. So what I'm going to have to do is to make this really clean this up. I'm just going to put this actually will be tied up here, but I'm running out of lines here. It's starting to get a little crunch. So I'm just going to say that's A. And then I'm going to have B. Well, the B is easy to do. I just tie it right in here. And then C naught is my inverted. And I'm going to say that actually you can take it off of here. I'm going to take it out. Yeah, I can take it off of there, but I'm going to take it right down here. So in reality, we really don't need. We don't really need this third knot because we could take it off that side. And then we're going to take this to OR. So we're going to bring this to an OR. And that is our Y output. There it is. So yeah, it's getting a little messy, but it's getting a little complex, a little messy, but that is 4-4.